All right, I see we got a decent chunk of you all on, so we can get started here a little bit. But yeah, so I know most of you I've had before, which is great, and a lot of you came right over from 120 in the first session. There's a couple of you that took 120 a couple semesters ago, but luckily 126, the material from this class is pretty different than circuit analysis 2. So even if you don't remember all of the concepts from circuit analysis 1, you should be okay for 2, because this one focuses primarily on AC electricity. Circuit analysis 1 focuses primarily on DC electricity. Of course, this one's 2 because AC is a little bit more complicated. The math is a little bit more complicated as well. So I guess real quick, in case I haven't had any of you, my name is Summer Grooms. I have been with Jackson College now a couple of years, but just started full-time in October. So I do come on campus every Tuesdays typically, but other days as well. So if you ever want to meet in person to talk through anything, I can do that. Or of course, online as well, if you ever want to have office hours or anything at all. I kind of just make it based on your schedule. And I'll put in the chat here, I don't know if you saw it in Canvas, but there's a link to schedule office hours with me. So I'm going to put it in the chat here. Again, just if you ever want to meet individually. So 126 works pretty similar to 120 in the sense that it's got both an electrical component and a math component. So if you didn't like that from 120, sorry, it comes back. Unfortunately, I think the math is a little bit more difficult in 126, primarily because it focuses on trigonometry. I'm an engineer and I've taken a lot of math, and trigonometry I always struggle with. So I know it seems like that's a common one that a lot of people struggle with. So just want to put that out there that it can be challenging. I believe Kim, hopefully she sent you all an email. She's your instructor for the math portion of this course, and hopefully she sent you an email. I think that she is going to meet with you all Tuesdays as well later in the day. So you'll kind of have 2 meetings. But that might be kind of nice because then they're like, you get them out of the way early in the week. But they don't, similar to 120, the math and the electrical work kind of line up with each other, but they're not like, the math that we do on the electrical side is not as complex, I would say, as the math side. But I would definitely log on to that math meeting today. Again, I think it's at 4. She should have sent you an email. If she didn't, let me know. And the Zoom link should be already in Canvas. But yeah, so kind of today, I always make this first meeting mandatory because for a lot of reasons. One, I just want to make sure everyone's clear on the requirements of the course. 2, I have to do attendance every week, and especially the first week, there's a lot of students that kind of drop and re-add a different class. So that way everyone on today, I know you're fully enrolled and I won't accidentally drop you because that happens a lot. But with that, today I'm just going to kind of go through the syllabus, talk through any basics, and then I am going to talk a little bit about week 1, and then you'll be good to go. And I see, okay, there's a note in the chat that you didn't receive an email yet. Dang it. I'll give Kim a call after this and make sure that she has the roster. Sometimes they don't give her the roster right away. But yes, the meeting is today. It should be today at 4. I had put that in Canvas because that's what she had said, but I'll verify after, and you'll probably get an email today if you have not already. Oh gosh, my office for some reason is lights automatically turn off, but okay, here we go. Well, thanks. That's good to know. But yes, it is today. I'm pretty sure at 4. Actually, look, I have it on my phone just to verify. Yeah, 4 to 5. So, the one nice thing about the math though is there's only 5 weeks, I believe. So you get done with the math a little bit early, but this is a 7-week course. Okay, so I'm just gonna pause and just see before I get too far into things, see if there's any questions, concerns, anything like that. Besides the concern about the math not getting an email, I'll take care of that and meet with Kim after this. But any other questions, concerns, anything at all? All right, not hearing anything. That's a good sign. And yeah, so I'm gonna pull up the course here and we'll get started talking through the content. Okay, so one thing is there's two sections of 126. So you'll see I-60 and I-61. You're in one of those two sections. So they're used interchangeably. So it's fine. If you hear me say I-61 and you're in I-60, it's okay. So again, it works pretty similar to 120. These, if you didn't know, there's a student success quiz and a programs of study by pathway guide acknowledgement. They're pretty straightforward, but I like to have those in there as extra credits. So if you want to do those, it'll boost your grade a couple points. Under this general tab, you'll see the Zoom link for the math. Here's the Zoom link for the electrical. This is the book that we're going to be using. So if you click on this, it'll open up the full book. And then if you click on this ELT 126, this is the syllabus. And I'll go through this pretty quickly because it's pretty similar to what you've seen. But again, this is a 4-credit course. So you've got the electrical theory and the math theory portion. Again, it's about AC electricity. This is important to note. 120 is a prerequisite for this course. And when a course is a prerequisite, it means that you have to at least have gotten a 2-point in 120. So all of you on this call should know what you got in 120. The grade should be available to you now. If you did not get at least a 2-point, you can't take this class. So if they didn't catch it, I would definitely shoot your navigator an email because it could be a way bigger concern, like in a couple of weeks if you start taking this course. So just be mindful of that you need a 2-point in 120 in order to take this class that you're in right now. You don't have to buy a textbook for this course. We have it linked in Canvas, so you don't have to worry about that. Grading procedure, again, works pretty similar to 120. So the bulk majority of your grade comes from the electrical quizzes, 100 points. Math quizzes is 65 points, and then amateur modules are 35 points, which means that each amateur module is worth 5 points. And just to say this too, I will focus a little, probably not so much this week because it's I don't even know if there's an amateur module this week, but if there is, it's pretty straightforward. But going forward, I'll start focusing a little bit more on those amateur modules, specifically the parts that like have you simulate things, because some feedback from last semester and from 120 from a couple students was that it didn't always work right. And obviously that's a big component to understand just like the hands-on portion. Even though it is an online course, of course, the simulations at least kind of give you an idea of some hands-on items that you should know for the course. So I'll focus a little bit more on those amateur modules as well. Of course, we'll still talk about the theory side of electrical, just because that's the main component. So grading scale works pretty similar to what you've seen before. The rest of this is pretty straightforward as well. As far as attendance going forward, these are not going to be mandatory. I will record them typically, or at the very least, I'll at least send the PowerPoint that I went over. So just be mindful of that. And if you want to make sure you get attendance each week, it doesn't count as a grade, but I have to record attendance each week because we monitor it. And if a student is not active for 2 weeks, I have to de-enroll them. So make sure that you're at least completing some work once a week on Canvas, whether that be the math quiz for the week, the electrical quiz, or the amateur module. I will say that technically there's no due dates for the course, but definitely I would follow the typical weeks in Canvas because it's very easy to get behind in a 7-week course, and there is a lot of stuff to do, and that's just because we condense a 4-credit course in 7 weeks. The rest of this is pretty straightforward. So this is, again, 7-week course, the last day of the course. So it started yesterday. The last day is May 3rd. So be mindful that that's a Friday. A lot of times you have until that Sunday of the last week. This situation you don't, just because of graduation. It's the 4th, I believe. So all of your work has to be completed by May 3rd. Anything that's completed after May 3rd will be an automatic 0. So be mindful of that day because it's going to come up quickly. All right, and then this is just an idea of the schedules of what we're going to talk about each week. So week 1 is all about magnetism and electromagnetism. 2 is when we start talking about alternating currents or AC. And then kind of through that, we dive into more specific topics. So like capacitors, inductors, RLC circuits, transformers and motors, and then polyphase circuits. So that's like phase 1 and phase 3 typically. So yeah, this week is a little bit confusing because I always say it's kind of abstract. Talking about magnetism, it's kind of sometimes difficult to like conceptualize. The weeks that follow are a little bit more typical to how 120 works, where we draw circuits and it's a lot of math. So I will say like when we do, especially week 3 through week 5, it's a lot of math in terms of like solving the circuits, right? So it's typical to 120, how like we had to solve the circuits for all the different parameters, kind of how this works as well. We're just dealing with alternating currents, which again are a little bit more complicated. But yeah, so with that, that's the syllabus for this course. Again, main things are if you're not going to attend these meetings or if you can't attend them moving forward, make sure you're completing the work each week. For attendance reasons, you all should have my email if there's any questions, any concerns, or anything like that. And yeah, so with that, just to kind of show you, well, I'm gonna pause again. Any questions about the grading or the syllabus or anything that I just went over? All right, not hearing anything. So I'm hoping that means I'm explaining everything clearly and not confusing. Okay, so you'll see that everything is kind of outlined for week 1. So it is a lot of stuff. So of course the videos are pretty short, but I recognize that. So it's definitely can be a lot. But again, it's a 7-week course. So that's kind of the nature of the course. So week 1 is kind of broken up into 2 components, and that is magnetism and electromagnetism. So we'll talk about both. There's a couple videos that are interesting to watch, and then you'll see that you have a quiz 1 practice and then your regular quiz. So I'm not sure. Let's open this because I'm not exactly sure what the practice quiz is. So, okay, so just asking you a couple like word questions. You don't have to actually fill this out, but it's just a good idea to kind of skim this and make sure that you understand the answers because I think it's helpful for the quiz. But again, you don't have to like fill this practice quiz out and submit it to me. And then you'll see that the math is the same way. So you have math 1, week 1 is dealing with Pythagorean theorems, probably all familiar with that. And I will say that that definitely comes into play in week 3 and week 4 of the electrical side. So if you don't understand Pythagorean's theorem this week with Kim, definitely reach out to either her or me because you will really struggle when we get to the electrical courses. And it's kind of like you'll get watched twice, right? Because if you don't understand Pythagorean theorem, you'll get those questions wrong on the math quiz, but you'll also get them wrong on the electrical quiz. So just be mindful of that. So like I said, it's a lot of trigonometry, which if you like trigonometry, that's great. But if you're like me, who does not like it, it's not too fun. And then, like I said, so you'll see that after week 4 of the math, or after week 5 of the math, there's just a few videos for week 5 of math. There is no more math after that. So you go right from week 6 and week 7. The other thing you'll notice is the amateur modules is all down below here in its own separate unit. So do not forget about those. The reason I do that is just because sometimes they don't always, like, for example, there's not one that like goes too well with this week. So you can kind of do these whenever you want. Obviously, when we talk about like inductors and capacitors, I'll go over this amateur module and talk through it a little bit. Same with like motors. When we talk about that in week 6, I'll talk about the motors amateur module. But Just be mindful of those, that they are still a requirement and they're kind of hidden all the way at the bottom. And I believe it'll say in the week 1 to do, if you click on this, it'll say which one is suggested to do. So for week 1, it's suggested that you do the sequencing control module, but if you want to save that for week 2, just because I know the first week's kind of overwhelming, that's okay too. You'll just have to do 2 in 1 week. But yeah, so that's basically how the course is laid out. I'll say again that week 3 and week 4, where this course can get a little bit tricky. There's a lot of math involved, and that can get confusing. So just be mindful of that. Definitely keep up the work. Highly encourage you to come to these, and we can talk through and slowly kind of work through the problems. But if not, definitely stay in touch so we can make sure that you are good to go. So with that, I'm gonna kind of switch gears and talk about week 1, unless there are any last minute questions. And I'll save time at the end as well for the first week in case there are any questions or concerns, but giving you another chance now. All right, not hearing anything. You pull up week 1. And another thing I'll say, when you go to study, sorry, I have a lot of slides up here. When you go to like do the work for the first week, you'll see there's not too many videos because a lot of this requires you to read. It says Grab's book, and then it says chapter 1. So there's a lot of reading, but I'm one that likes to just read through things, and that's how I learn best. If you don't learn best like that, that's kind of the point of these face-to-face Zoom calls, is we can kind of I'll answer any questions, and I'll try to really focus on the main concepts that are important to understand for the course, just because obviously for a lot of you, maybe reading 3 chapters in 1 week is way too much information, and it's difficult to kind of narrow down and prioritize what's actually important. So I'll do that as well in these meetings, kind of like narrow it down and give you what's most important to kind of take away from that week. So when it says Grab's book here, what that's referring to is the PowerPoints that are embedded each week. So you can see that in week 1, it says lecture 1, magnetism. I should be able to, oh, not that, sorry. That's an actual video. It says week 1 PowerPoint. This is the one I meant to click on. So if you click on this is Grab's book. So it's not technically a book, it's like a PowerPoint. I will say that this has a lot of information, which is helpful, but sometimes it's a little bit too much and it's kind of dry and it doesn't always explain things clearly. So sometimes I might pull these up and kind of talk through some of the images and kind of what's important. So just be mindful of that. So when it says Grab's book, it's referring to that. So there's nothing you have to buy for the course. It's referring to those PowerPoints. So yeah, so like for week 1, there's just that quiz 1. Really, it's just these couple things here that you have to review. If you do all of those, that should be more than enough to kind of set you for success for week 1. Okay, so with that, switching gears over to my short PowerPoint, just because week 1's pretty short. So electricity, it comes up in any electrical course here you'll have. And I will say too, I'm gonna save time at the end too to talk through, since a lot of you are kind of at least a good chunk of the way through these electrical courses here at Jackson College. I want to make sure that all of you are aware of like what pathway you're doing, just because sometimes it can get confusing. And now that you take ELT 126, this is kind of one of the last like prerequisite courses. So after this, you either go into the upper level electrical courses if you're staying in the electrician's pathway, or you might go in like a manufacturing pathway. So we'll save some time at the end to talk through that too, because I think that's important. But again, so what is electricity? Hopefully we've talked a lot about this in 120. But essentially, electricity is just that imbalance of electric charges. And when we talk about electric charges, we're talking about the electrons, right? So when we have our electrons moving through the wire, just like we showed anytime that we drew a circuit, that's kind of what causes or creates electricity. So it's that movement of electrons. Electricity in itself is kind of like a secondary form of energy. So it can, energy and electricity sometimes are used interchangeably, but essentially electricity is the byproduct of energy, is how I would think about it. So with that in mind, it can produce light, heat, and motion. And we all know that, right? Because it can produce light in the sense of the lights in the room, heat in the sense of, um, well, heat, right? And then motion, of course, any like a fan spinning can create motion. So the other thing to note is that voltage causes a charge imbalance that can kind of cause those electrons to move through the conductor from one region of a more negative charge to a region of a more positive charge. The reason that I put that in there is because in a minute here, we're going to talk about magnetism and the relationship between the attraction and repulsion of objects. And that's important for electricity as well, right? Because the electrons are negative and they want to move to an area of positive just because, opposite signs attract, right? So voltage, what we learned last week or last course, is kind of the force that pushes and pulls those electrons. And that's because it creates or causes this imbalance of charges. So those electrons want to kind of reach a more neutral state. Okay, so now what is magnetism? So this is where it's kind of confusing to understand like how magnetism comes into play in electricity, but really they kind of go together, electricity and magnetism, hence electromagnetism. So magnetism is a physical phenomenon. So it's created by moving electric charges. So I highlighted that to kind of emphasize like this is one way they're related. So essentially a magnetic field creates an electric field and vice versa as well. So that's kind of why we're talking about it here too. So a magnetic field, it is what induces those charged particles to move, which creates an electric current. So it kind of works the same way as voltage. So it's creating an electric current. When it creates an electric current, what that means is our electrons are moving through a circuit. And that's important, right? Because without a current, without those electrons moving through a circuit, we wouldn't have electricity. Similar to electricity, magnetism is also related to the attraction or repulsion of objects, right? So we're probably all aware of this because if you have a magnet, we know it has that south pole and the north pole. So unlike electricity that has is related to positive and negative charges, right? Because we have electrons are negative, things like protons are positive. Magnetism is related to the Earth's magnetic field where we have the south and north pole. So similar to electricity, where we have positive attracts negative and negative repels negative, south attracts north and north repels north. So like charges repel, opposite charges attract. And that's easy to visualize with a magnet, right? Because like if you have the two negative sides together, like you know how they'll like repel from each other, whereas the two positive sides will come together. But yeah, so that's just kind of the big thing here is just understanding the fact that magnetism and electricity go hand in hand when talking about the fields. And it's also similar in the sense that they both have some sort of attraction and repulsion force. Okay, so now this is where two new terms come into play, and that is magnetic flux and flux density. So these are two terms when talking about magnetism and especially the magnetic field that are important to understand. And it's also important because in weeks to come, these are things that we'll have to calculate. So magnetic flux is essentially referring to where we have a magnetic field. It's the number of lines of force that is flowing outward from a magnet's north pole. And this is the best way that I could kind of think to visualize it. So it's essentially that force kind of flowing outward. So you can see that this is a magnetic field and all these arrows are pointing up. Flux density relates to that in the sense that it's how close those lines of flux are in the magnetic field. And it makes sense if you kind of take a step back and think of what density is. So density is like how dense something is, means like how compact it is, right? And so if we have flux density is how close those lines are together. Like if they're really close, there's a lot more flux density because that means that those lines are closer together and it's more dense. So that's a good way to kind of remember it. And flux density is measured in something called Maxwell's. So essentially you can easily count flux density by counting the number of Maxwell's or the number of lines. It's important to note too that the higher the density, the stronger the magnetic effect, which also makes sense, right? Because high density or high flux density means that we have a lot of lines close together, which means we have a lot more forces, right? So that is a stronger magnetic field. And that's when I'm going to flip over really quick to the magnetism grabs book, just because I like the visual that they give in this. So you'll see that the beginning just talks about what we talked about a minute ago when talking about magnetism. But there's this slide here is a good depiction of magnetic flux. So this is showing both magnetic flux. Hopefully it switched to this. Let me know if it didn't. But this is a good depiction of showing kind of visually what magnetic flux is. So again, magnetic flux, and I think I actually said flux density a minute ago, but magnetic flux is what's measured in Maxwell's, not flux density. And again, that's the number of lines. So the number of lines is the flux or the magnetic flux. So you can see here that it's a number of lines that kind of comes off the North Pole. So if you count these lines, you have 1, 2, 3, 4, 5, 6, right? That's the number of arrows, the number of lines of force coming off the North Pole. That's your magnetic flux. So again, the magnetic flux here is 6 Maxwell's. 1, 2, 3, 4, 5, 6. So you can see here that that's the total flux, 6 lines or 6 Maxwell's is how you would write it out. As in terms of flux density, we can also technically calculate that there's no, in this slide, they don't give us like a legend that shows like the scale, but essentially, again, it's the distance or how close those lines are determines the density. So the closer those lines are, the more flux density you have. So this is what it's saying when it's referring to this P here. So it says flux density B at point P is 2 lines per square centimeter or 2G. So what that's saying is if we zoom in here, which my touchscreen doesn't work because I cracked my laptop, but if I were to zoom in here on this P where you see this green square, what it's saying is from this line to this line, technically that distance is, or I guess maybe that area is 2 lines per square centimeter. So in this square here, this is 1 centimeter. Obviously it's not to scale, but if this is an area of 1 centimeter square, there's 2 lines in that area, which means that we have 2 lines per square centimeter. So you would say that as the flux density is 2G or 2 Gauss, because that's a unit for density. So again, it's the amount of lines in a set area. Because again, the more, like, let's say if there was a third line in this, then it would be 3 Gauss. So again, it's just the amount of lines per set on an area. Any questions on that? Does that make sense? Again, main things are understanding magnetic flux and flux density. And again, these terms are in relation to the magnetic field, which is what this picture is of. Okay, well, hopefully that made sense. Keep moving on here then. I have a short video that I want to play on electromagnetism in a minute here, but essentially electromagnetism, that's the term that kind of combines electricity and magnetism. And again, it goes back to the idea that a magnetic field is created by the flow of electric current, which means when we have an electric field, we have a magnetic field. And essentially the reason this is important is when we have like a coil, which in the Grabs book, they talk about this as well. Oh gosh, sorry, my computer froze for a minute here, but in Grab's book, they talk about the coil. Somewhere in here, it might be in the second one. You can see too that like as I'm scrolling through this is a lot of information. So when you go to like take the quiz, a couple things that are not too relevant. It talks a lot about the air gap of a magnet. I would say you can probably bypass this area. I mean, I would definitely read it, but it's not too relevant for the weeks to come, and it's not too relevant in terms of like what you're supposed to take from this class. So you can kind of bypass all of where it talks about that. It goes into talking about the different types of magnets. Obviously, for this course, and this is what I was looking for, the main type of magnet we're talking about is an electromagnet, and that's essentially when you have like a coil of wires. And so we'll talk a lot about how that kind of impacts electricity. So when talking or when reviewing this, permanent magnet is important, but really the electromagnet is what's important for this class. And this is kind of a good example of what it looks like. So you have this coil of wires. So this causes a magnetic field. Okay, so sorry, I know I'm kind of bouncing around a lot, but it's just because there's a couple things in Grab's book that I wanted to make sure I talked about. So again, when talking about electromagnetism, I really liked this diagram on the right here, which I'm going to make bigger for you. And it kind of shows a side-by-side comparison of a magnetic field and an electric field and what terms are similar. Because I know when talking about magnetic field, it's difficult, again, to kind of conceptualize like these abstract terms and like what they mean, especially in terms of electricity. So this is kind of showing a comparison of what terms are related to what. So in an electric field, we know that we have the electrical current, right, which is the flow of those electrons, right, like that force of the electrons moving through a wire. So that is similar in a sense to the magnetic flux. Flux density, on the other hand, which again is how dense that magnetic field is similar to current density, which is something that is produced when you have an electric field. Magnetic field strength, so the strength of a magnetic field is the same thing in an electric field. So obviously electric fields and magnetic fields have certain amount of strengths. Permeability and conductivity, we'll talk more about that in weeks to come. Likewise, inductance and capacitance, we'll talk a lot about that in I think week 3 and 4. So in week 3, we'll talk heavily about inductance, and then in the following week, we'll talk about capacitance. Those two terms are kind of opposite of one another, but of course, they're similar as well in the way that you calculate them. So we'll talk about how you would do calculations for finding inductance and capacitance in weeks to come. And then finally there, energy, right? So when talking about magnetic fields and electric fields, the main component here is that we're creating energy. So that is also something that is and can be calculated. Okay, so I'm going to just play this short video, and it kind of just shows the relationship between electricity and magnetism, and it's a good kind of overview. It's only like a few minutes long. I never play long videos because they lose my attention. So I'm sure they lose yours too. So, okay. Let me make sure that I have the sound on this. Or oh, how do I turn the sound on? Advanced sharing options. Well, hopefully you can hear the sound when I'm about to play this video. If you can't, I'll talk through it, which I'm sure you'd rather hear the video than my voice, but okay. So sorry, just one moment. Okay, so the screen should load. I'll make it full screen and play the video. So with that in mind, and I know I'm already pausing this, but essentially what that's saying is electromagnetism is like a natural force on Earth. And that's because it goes back to the fact that we have the North and South Pole, right? That is a naturally occurring magnetic field. I'm gonna pause here because this is important as well. Frequency comes into play in weeks to come. And again, it's because when talking about magnetism and waves, kind of goes hand in hand. So you can see that these are all the different types of waves. So this is like the electromagnetic spectrum for like the frequencies of waves. And I see there's a chat in here. Could you guys, dang it, there isn't any sound. Okay, well, I'm not gonna play the rest of this video then. But I'll put the link in. I'm gonna put the link to this because it's only 3 minutes and I would watch it. Again, it's just talking about electromagnetism and the relationship between electric and magnetic fields. So I'm gonna put this in the chat. I'm sorry about that. I'm so mad. I really wanted that to work. I know there's a setting somehow. So if any of you know the setting for like that, but it's fine. So I put that in the chat. Again, I won't play it because it's kind of a mute point now. Share my screen here. So just the last little bit on this week is talking about motors and generators. So the reason we're talking about this is because of the fact that motors and generators are an interesting concept because they kind of work very similar but opposite. So we all know what a motor is, right? A motor is, like you have motors for various different things. We all know what a generator is, right? So it's producing electricity. They're both kind of forms of energy, but they're opposite forms of energy. So with a generator, we are creating electrical energy. And you should all know that, right? Because like if you have a generator in a house, you turn it on when you lose power or lose electricity, and it's going to continually give you electricity. And the way that a generator works is it's essentially converting mechanical energy, which mechanical energy is energy that's moving into electrical energy. And that's important to know. So again, you've probably learned this in previous classes, but we learned this, I know, in 120. Electricity or energy, I should say, energy can never be created or destroyed, right? It can only change forms. And that happens all the time, everywhere. And that's essentially when we're harnessing electricity, that's what we're doing. So we're just taking one form of energy and converting it into electrical energy, which is a useful form of energy for us, right? And that's how renewable energy works, because we're essentially all forms of renewable energy are harnessing one type of naturally occurring energy and just converting it into electrical energy. So for example, wind wind turbines, which they showed in that National Geographic video, which I linked, is essentially wind energy, right? And what's happening is you have, in simple terms, the wind is motion or movement, which we know movement is essentially kinetic energy. And that causes that the motion of the wind is causing that the turbines or the propellers to spin, right? And that's creating mechanical energy. Mechanical energy is just like movement in the form of like a gear. And then essentially that box inside those wind turbines is converting the mechanical energy into electrical energy, which is, the useful form of energy for us. And same for any type of energy, right? Like solar energy is doing the same thing. It's harnessing energy from the sun, converting that thermal energy or heat energy into electrical energy. So that's the way energy works, the way power plants work as well. It's taking heat or steam energy and turning it into electrical energy. So all of that relating back to the slide going on right now, that's what a generator is doing. So it's converting mechanical energy into electrical energy. And that's why it's always there, because mechanical energy doesn't rely on like the outside power source. But on the opposite version, a motor internally is basically harnessing electrical energy and converting it into mechanical energy, which makes sense, right? Because we have motors to move. So they work opposite of each other. One is converting electrical energy to mechanical energy. One is converting mechanical energy into electrical energy. Now, the reason that we're talking about it in this slide or in this class is because the way that you start with electrical energy or mechanical energy in a motor and a generator is through a magnetic field. So you can see here on the slide here that if we looked internally at a motor and generator, what's happening is there's this armature inside, and you can see that rotating right now, right? And what's happening is it's getting kind of pushed from one side or the other because of that constant attraction between the North and the South Pole. Is kind of pulling it from one side to the other. So it's rotating. This rotating piece is what is the mechanical energy portion, right? That rotating is creating mechanical energy, and that's when we can either convert it into electrical energy or vice versa. And so there is, and again, I guess if you don't have if it might not work, but there's another video that I wanted to play. I think it's this one that shows the difference between how a generator works and how a motor works. But again, it's the same concept. It's just one's converting from electrical to mechanical and one's converting from mechanical to electrical. Let me see what video it is. Might be this one. So this video here talks about the magnetic field of a coil. Another interesting one to kind of take a look at. This is the one I wanted. So I'm going to play this video. I know you can't hear it, but we'll talk through what's happening. And I'll link this as well. This is, again, the one that's showing a generator versus an electric motor. I'll link this one here in the chat so you can watch, but we'll talk through it because we'll get the main ideas through it. It's only a minute or two. So first he's going to show a generator. And again, it's showing the internal components of a generator. So this is showing the pictures of the important components here. So that armature is what I talked about a minute ago. Is the main thing that's moving. So essentially what's happening is you have a magnet, right? So you have a north and a south pole. So that, what they're showing right now, this is a magnetic field, right? Because we have the attraction between the north and the south pole. So essentially this armature here is a coil, and that goes back to the idea that, electromagnetism is related to the fact that we have coils of wire. So these slip rings just kind of go on the end of the coil, and you'll see that when that armature starts to move, and again, the armature is starting to move because kind of like the same way that electrons move, that push or pull, it's getting pushed to the south side because of the attraction. And then obviously when you're on the south side, it wants to move to the north side. So it's just constantly rotating because of that um, magnetic field attraction. So once it's rotating here, you can see that this whole unit is rotating. And the other components are kind of irrelevant, but really it's just the main concept here is that magnetic field is causing that whole unit to rotate, and that creates mechanical energy or electrical energy, I guess, in this sense, because this is a generator. It's creating electrical energy that you can harness. But with that, that was really all I wanted to show. And gosh, I see when you said your screen froze. I hope all of you can still see me. Really, I would just say for this week, I would go back and watch that generator versus motor video just because I think it's helpful, but hopefully I explained it clear enough. Again, main idea is all we're talking about is that energy is constantly changing forms, and we typically change it into the form of electrical energy for us to use. I'd watch that short video on electromagnetism because it's kind of interesting and helpful. And then really quick, since we have time, just to show you the quiz for this week. I'm not going to give you the answers, but just to kind of give you an idea since it's the first week. So this quiz 1 here, this is what constitutes your grade. There's only 10 points. So there's just 10 questions, and talks a little bit about what we talked about today. So what magnets are, their relationship between electricity and magnetism. And then there's a couple questions on flux and flux density, which we talked about. So hopefully those will be straightforward. And then a few questions on a generator versus a motor and what they do. And motor question and a couple more generator questions. So really that's the main idea. Just talking, the main things to take away from this week are just understanding the basics of what magnetism is. You already know the basics of what electricity is, and then just the basics of how a motor and a generator work. So definitely I would go back and take a look at the magnetism PowerPoint, the electromagnetism PowerPoint, and that's really all you need. The only concepts you have to learn from this week. Again, as a reminder, make sure that you keep up with those amateur modules. So next week, we're going to talk about AC power and AC electricity in more detail. And you'll note that there's 2 quizzes for next week. So just be mindful of that some week there are 2 quizzes. Next week is one of the unfortunate ones. With that, I saved 10 minutes for questions. So if there's no questions, I hope this was helpful. Hope to see you all next week. I know it's kind of a weird time, but hopefully it works with your schedule. If not, anytime you want to meet throughout the semester with me, please let me know. I know it can get challenging this course, so I'm here to help any way that I can. But if there's no questions, you're free to go and enjoy the rest of your Tuesday. And yes, I can put that PowerPoint that I just talked about, and it has the links to those videos anyways. I'll put that in the slide right now, so you have it. But yeah, any other questions, feel free to ask now. If no questions, feel free to hop off and enjoy the rest of your day. So how do I add file? So I'm putting this in the chat now. Sorry, it took me a minute to find the video or the PowerPoint. Where are you? (126) week 1. Okay, so it should be in there now. It's loading. So you should be able to just click on it and open it up. But yeah, so any other questions? I see there's a few more of you still on, so I'll wait. David, any questions for you or Braden or Mitchell? I see you guys are all on.
No questions out of me for this class.
Okay, sounds good. Well, thanks so much and hope to see you next week. And yeah, reach out if there's anything.
I'm supposed to be in your next class for residential.
Hey, oh, that's 2 hours in a row. Yep, it'll be a different Zoom link, just so you know. So
Yeah. Well, I was gonna ask, do you need me to show up for that one? I'm not feeling too hot right now.
no, it's okay. It'll be recorded as well, but thanks for letting me know. Hope you're feeling better.
I just figured I'd ask because I know it says it's mandatory, obviously, for the
Yeah,
attendance
no,
purposes. But
as long as you're here, I know at least you're still enrolled in both of them, but definitely watch the recording because that class it's a little bit different than the way this one's run.
okay, I can do that.
Thanks.
Thank you. Have a great day.
You too. Brayden, any questions for you?